Good morning, everyone. This is my presentation for our ISTC class. My final project, I focused on trigonometry. There's a new trigonometry curriculum being developed, so I thought I could try and develop some resources that I could use this year in combination with other resources given out by the county. So for the purpose of this, I tried to pick aspects of trigonometry that I deemed important. I really enjoyed having the students mimic the process of a mathematician and getting to see what mathematicians do both in the time of antiquity, something that like Pythagoras would do, versus what a current mathematician would do. Students always have a huge impact on material like trigonometry just strictly because of how dry it is. So I really tried to make this a student-driven set of activities so far. To see how trigonometry fits in their current cognitive structure is absolutely critical. Trigonometry is the link between algebra and geometry. The logical aspects of geometry versus the visual aspects and analytical aspects of all these different types of mathematics all come together in trigonometry. So I want to see them make these connections sometimes on their own in a discovery format or sometimes in a more direct format, because a lot of this information is so difficult that the most effective way to get it to them can be direct instruction as well. The class description, I'm going to use the class that I had last year because I do not know my current students' information very well. It was 2 classes of 11th and 12th graders consisting of 57 students. We're a magnet program at Parkville High School, so the students have a very high digital literacy, and they are, much quicker even than myself with the devices. They can troubleshoot very quickly. So having them use devices is not going to slow them down. It's not something new to them. They know how to pick up a calculator. They know how to pick up a device and get working immediately. And students also enjoy the investigative aspects of it. So I try to utilize both the interest of the student, my knowledge of the history of mathematics and the content, and try and mix it together to deliver a series of activities that can help show students the connection between all that they've learned so far in mathematics. Now, the one that I tend to use most frequently was Bruner's discovery learning. As many of you guys know, the discovery learning is probably the most heavily taught pedagogical strategy, along with constructivism at Towson University. And what was really nice, and the reason why I chose a lot of his styles, is because he speaks a lot specifically to mathematics. Because mathematics is all a discovery-based, the mathematicians were using discovery to find it. Why not have the students mimic that process and do the discovery process on their own? Though this can be time-consuming in some circumstances, one, it is absurdly helpful with retention, and also if they forget how to do it, they can repeat the process, Now, the one thing I want to draw attention to on this slide is Bruner's definition of discovery. Now, a lot of people think discovering means you have to discover something completely new. And that's not the case. It's having the students discover something that possibly already exists, but in their own set of parameters, and starting to understand that obtaining knowledge on their own is discovery. And this is absolutely critical for students, in a math class and not inside of a math class. Teaching kids to learn on their own will make them more successful than they previously were. It's a very metacognitive skill. It teaches the students to teach themselves. And as, trig is a college subject matter. It's college level mathematics. I'm trying to prepare them for college level mathematics. So let's get into the lessons themselves. There are 10 lessons, all dealing with different aspects of trigonometry. Again, connecting the algebra to geometry was my key focus. The first activity we're looking at is a Pythagorean theorem activity. So I'm trying to have the students link the algebra of the Cartesian plane versus the right triangle properties of geometry to bring in right triangle trigonometry. The activity that they're going to be doing is a Chinese theorem proof. This was the original Chinese theorem using a series of blocks. So they will be cutting out sheets of paper, kind of rearranging them and using their knowledge of area and perimeter, as well as algebra variable manipulations in order to come up with this theorem. The assessment is going to be a Quizzes, which, as you guys know, is a digital assessment tool. You could also do it in BCPS 1. I just like the quizzes because it's a little bit more fun and they get, it's a little bit more game-based. So this is kind of a more traditional assessment because, even though they're doing a non-traditional, very tactile learning in the activity, the assessment, they need to be able to show the application of it. So that's why I had them do the Pythagorean theorem proof, because they've seen the proof before. They've seen the Pythagorean theorem before. What I want them to do is see the variety of applications that it can have because of the Chinese area proof. What they're going to be doing, or the learning theory used, is Bruner's discovery learning. The reason why is because in order for them to truly grasp and understand this critical, one of the most famous mathematical theorems, is they need to see its proof and origin. And when they see that proof and origin, one, it's going to stick with them, and two, it's going to show them this vast variety. They get to discover their own proof. And that's something that really, sticks with a kid. They get to make it on their own. And because they make it on their own, they get to see the overreaching aspects of it. The second lesson is on solving trigonometric equations. The goal of this is to show students, again, the analytical aspect of algebra with the application of these trig ratios that they had learned in geometry class. Quick overview of the lesson. The students are going to watch different types of videos, and then we're going to do a jigsaw type thing. So the activity, like I said, we're going to split into groups. Each kid is going to master, or each group is going to master a different type of trigonometric equation. They're going to share these videos on our wiki. And then they're going to be using those wikis and put it into a graphic organizer. The assessment is going to be what I'm going to call a trigonometric cat box, or a maze. So based on those 8 types of questions, there are a series of steps that you have to do. So in order to get out of the maze, or out of the cat box, the student needs to complete each level correctly. So they're going to complete a level, check with me, complete a level, check with me, complete a level, check with me. And when they're finished, they're out of the cat box. But if they make mistakes, then they'll have to digress. This is a way for me to address the issues before it starts to compound. These questions are very long, and it can take a while. So if a student works through all the way and makes a mistake in the beginning, that error carries through, and that's going to stick in their head. So my goal with this is to eliminate the errors before they are repeated. The learning theory here is obviously Thorndike, who popularized these cat boxes. The reason why I chose this is I need to use the stimulus response aspect of the cat box to help eliminate the errors, again, before they become an issue. I want to develop strong, correct tendencies in mathematics as opposed to repeating silly ones over and over again. So my goal with the cat box was to eliminate those errors before they are repeated. Lesson 3 is the law of sines and cosines. Again, this is a very dry topic. So we're going to be using an advanced organizer so that way the students can see how it fits in their current cognitive structure. Because even though they don't know the law of sines and cosines, they will be able to complete problems using them because of their knowledge of geometry, and again with algebra as well. The activity is going to be the activity is almost a direct instruction. It's going to be kind of a learning walk, showing the different types of problems that can solve the law of sines and cosines. So it's really, they're looking at a problem, they're going to copy it down and kind of see how it fits in their current graphic organizer. Like, can I use law of sines here? Can I use law of cosines here? Or can I use Pythagorean theorem here? Or can I use trig ratios here? So these are all questions they can see, well, this is a problem I couldn't answer before, and now I can because of law of sines, or this is a problem I could solve before using Pythagorean theorem, but now I can use law of sines. So they start to see all these connections being made. Again, relating back to that graphic organizer. The assessment is kind of a fun one. It's a scavenger hunt. So they'll do a series of problems, find some different angles, and then it will get them to X marks the spot where they get to find the treasure, which is a little piece of candy, but spoiler alert. So the learning theory here, if you didn't pick up on it earlier, was the advanced organizers. Because this information is so heavily focused on what the aspects of a lesson that students already know, or skills that they already know, I just need to have them put all of those skills into one place, to physically see and visually see how this fits within their current knowledge of triangles, and it all starts to click. Now they can solve any type of triangle, not just a right triangle. Lesson 4 is the unit circle, probably the most critical set of data that you need for trigonometry. And their students are going to be doing a discovery activity for it. This discovery activity is a paper folding activity. So they'll be folding a paper plate. Off to the right, you can see an example of one. And what they're going to be doing is they're going to be using their previous knowledge, which is special right triangles, the Cartesian plane, and they're going to be linking that up to finding these coordinates and then eventually seeing these patterns. Because as you can see over here, the different colors annotate different special right triangles. So they'll be able to see these patterns develop on their own, or even come up with their own patterns that I may have missed or their classmates may have missed. The assessment for this, very straightforward, is just a timed unit circle. They will do this regularly. Because this is so critical, it's probably done at least 2 times a week or 1 time a week, because we have A day, B day. So they need to fill this out in 5 minutes using the patterns that they developed. The learning theory here is the Bruner's discovery learning. Because this is all something that can be done using the information they already know, they just need the guidance or the pathway to get there. And that's what the paper folding is going to help them do. Lesson 5 is the trigonometric identities, which is a super, super dry lesson. So I try and come up with some different ways to help it stick with them. The activity is really just a direct instruction so they can see all the different cases. That's the most effective way of doing it, because there's so many different types of proof. I need to get right into it and share with them, okay, these are the 8 types of proofs that we're going to be doing, or the 7 types of proofs that we're going to be doing. Here's just different examples of them. They'll use a graphic organizer to compile all the properties and theorems and identities that they already know. And we're going to call this graphic organizer a proof toolbox. So that way the kids have something to reference as we go throughout the unit answering these types of proofs. The assessment for this is pretty cut and dry. It's a scaled set of problems, so they'll work on a simple one, then they'll do a more difficult one, then they'll do a more difficult one, more difficult one, more difficult one, and it keeps building up, so on and so on. The learning theory here is Azubel's learning, or meaningful learning. The reason why I want to use this is, again, because proofs are so dry, my students need to see where this fits in what they already know about proofs from geometry and algebraic proofs and algebraic manipulation of variables from algebra. The only way for kids to wrap their head around this lesson, because it's so conceptually dense, is to relate it to their cognitive structure that already exists. Because they know proofs. I mean, they're difficult, but they understand the principle of a proof. Lesson 6 relates to parametric equations, and now this is the section. The second half is really focused on graphs. 6 through 10 is all really graph-based, and kind of follow a similar educational theory, and I'm going to kind of go a little more quickly through these because of that. We're going to be exploring parametric equations using Desmos, which is a graphing software where the students can do a discovery lab by adjusting. You can see the slider here. When you move the slider, it adjusts the graph in rapid time. So they can start to see patterns develop very quickly without having to graph something which may take 2 or 3 minutes. They can literally see 1,000 graphs in a minute if they so choose. So this will help them see some of the patterns that exist there. The assessment that we're going to be using is the kids are going to be creating their own set of data and their own set of functions to match a parametric equation. Sadly, I don't have a student example. What I did is I found one from a book that a student could use. It's a pumpkin being launched. And they're going to have to pull important pieces of information based upon the graph and based upon the parametric equation. Again, so that link of algebra and geometry here. As kind of discussed earlier, the learning theory is Bruner's discovery-based learning. They're going to be playing around with variables and developing patterns, which allows them to take ownership of this type of material. This lesson 7 is on polar equations. Students will be able to plot the key features and adjust key features using a CAS Inspire calculator. Here's an example of what some of the pictures look like. The assessment will be an argumentative piece. They're going to be writing about why we still use polar graphs, why they're important, why can't we use just rectangular graphs.